Today's lesson is relatively short, and all we're going to do today is just expand on what we learned about greatest common factor, factoring by grouping, and now we're going to take it to a next step called difference of squares. So, greatest common factor, again, we already know we're looking for the greatest common factor. Should be a capital G, shouldn't it? And divide it out. So we're basically doing the distributive property backwards again. So if you look at this, 2 and 8, 2 comes out of there. So you're left with x minus 4. 2 comes out of there. So you're left with 6x squared plus 5. 3 comes out of there. You're left with x squared plus 9. Let's see. X comes out of there, doesn't it? And 2. So 2x comes out of there, and you're left with 4 minus 9x, I believe. Because remember, x times x is 1 plus 1 is 2, x squared. Remember these. We take out the GCF, which is x plus 1. We're left with 2x minus 1. Take out 3x minus 1. Whoops, sorry. We are left with x squared minus 7. Take out y minus 3. We're left with 2x plus 1. Now, we've already done these. I realize that. Okay. Today, we're going one step farther. And it's not difficult, okay? But there's some things you need to recognize. You have to know the perfect square numbers. In other words, 1 squared is 1. That doesn't help us. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5, 6, 7, 8, 9, 10, 11, 12. That's through 12. You need to memorize those. If you don't have those memorized, you need to. But it's not hard to memorize either, because it's just 4 times 4, 6 times 6. If you know your times tables, it's quite easy. Now, what does this mean, this difference of squares? Difference means subtract. So, perfect squares, difference of, let me recalculate this here. Subtracting, let's do that. Perfect squares. All you do is take the square root of each. Well, if it's a squared minus b squared, then it's a plus b times a minus b. And that is always accurate as long as these two terms are both perfect squares. Now, addition, say we're adding, cannot factor unless it's GCF. That's the only thing we can take out as the greatest common factor. We cannot factor a plus as far as difference of squares, as far as perfect squares go. So we're actually going to take the square root if these are perfect squares. So you have to know your perfect squares. So if you start with number 1 here, x squared is a perfect square because it's x squared. 16 is right here. Well, what's the square root of 16? What times what gives you 16 by itself? 4. So it literally, all you do is write x plus 4, x minus 4. If you FOIL this, which I'm going to do, first, x squared, outside, negative 4x, inside positive 4x, last negative 16. That gives me x squared minus 16, because the outers plus the inners, this is F, O, I, L. The outer and inners always, in a perfect difference of squares, they cancel out. It's 0. Now, you don't have to check it like I did. You just have to memorize that if you have perfect squares and you're subtracting, it's always this form. Okay, look at 2. Is 4 a perfect square? Yes. Is 81 a perfect square? Yes. Is x squared a perfect square? Yes. So now we just take the square root. So square root of 4 is 2. Square root of x squared is x. So we're going to go, and you could put plus or minus, it doesn't matter. Square root of 81 is 9. So 2x plus 9, 2x minus 9. Can I write it in reverse order? 2x minus 9, 2x plus 9? Indeed, yes, you can. Okay, number 3. Is 4 a perfect square? Yes. Is x squared? Yes. Is 25? Yes. So what are the perfect squares? Well, 2x plus 5, 2x minus 5. That's it. This is just something you memorize. Okay? Now, 4, 18 and 98 is not up here, is it? So it's not a perfect square. So what do you always look for first? The first thing you always look for is the greatest common factor. Well, I believe 2 goes into both of those. So if I take out a 2, I get 9x squared, and 98 divided by 2 is 49. Haha. Now do we have perfect squares? Yes, 9's on there, and so's 49. But you can't lose the 2. So just keep the 2 out front. So the square root of 9 is 3. The square root of 49 is 7. So it's 3x plus 7, 3x minus 7. And all of that times 2. So we got to put a 2 out front. Okay, so fast forward that, or rewind that and look it over. See what you think about that. Number 5, x squared minus 1. Well, again, those are both perfect squares. 1 is a perfect square because 1 times 1 is 1. So all it is x plus 1, x minus 1. Just take the square roots. Number 6. No, 50 is not up there. 72 is not a perfect square. These are both even numbers, so we know 2 goes in there. How many times? 25 and 36. Now, are 25 and 36 perfect squares? Yes. What's the square root of 25? 5. What's the square root of 36? 6. So it's 5x plus 6, 5x minus 6. This is called the difference of squares. Now, just to review, I don't want to just take off here. I'm going to give you a couple more. So just to keep you focused here, let's do a couple more difference of squares. And I lost my difference of squares. Where'd it go? There it is. Okay, so what about b squared minus 9? Do that one quick. Well, is b squared a perfect square? Yes. Is 9 a perfect square? Yes. What's the square root of 9? 3. b plus 3? Oops. Try that again. b plus 3. b minus 3. It's not so bad, is it? How about n squared minus 64? Yes, 64 is a perfect square. It's 8. Square root of 64 is 8. So n plus 8, n minus 8. All right, what about this? X squared plus 4. Can we factor that? No, because it's a plus sign there. Can't do it. Okay. Your assignment today is very short. It's just that worksheet with factoring the difference of squares. It's the back page of the worksheet, 13 through 24. But I also have a Monday's extension, and Monday's extension is doing a couple more of each. Okay, so I'm going to just do a couple problems just to keep you focused on what we're doing. All right, so this one, we're looking for this going, okay, GCF first. It's got 4 terms, remember? So this definitely isn't difference of squares. Well, since we have 4 terms, we always look for the GCF anyway. Well, 7 doesn't go into 24 or 6. So this must lead us to this conclusion. Remember this? Factoring by grouping. So yes, we have to remember how to do this. We have to. So we look for the GCF here, remember? And that's a 7x and I believe a squared, because we have a 2 and a 3, 2 smaller, so 7x squared comes out. What's left? Well, divide by 7, you get 4, and then you need an x, right, to get x cubed. But we took out 7x squared, so it's just a 1. And remember then the process is we write it again. Then what? Do you remember? We divide the last 2. -6 divided by 1 is -6. So then 7x squared minus 6 and 4x plus 1. Now I wrote that in reverse order of what I showed you last time. 4x plus 1 times 7x squared minus 6. It's the same thing. Okay? That's a grouping problem. Let's do another grouping quick. 35 n cubed plus 49 n squared plus 5n plus 7. Again, there's no GCF there, guys. 5 and 7, no way. So you got to do this. Now, what's the GCF of these? What goes into 35 and 49? If we know our times tables, it's 7. And then we have an n squared and an n cubed. So you take the smallest one out, n squared. So let's see, 7n squared comes out, so that leaves me 35 divided by 7 is 5. N cubed divided by n squared, I need another n. 49 divided by 7 is 7. And then we rewrite it. And then, of course, remember, you just divide those last 2, and that's a 1. 7 divided by 7. So our factors then are 5n plus 7 and 7n squared plus 1. Factoring by grouping. Let's do one more GCF as well. 15 plus 18r minus 30r to the 5th. Okay? What's the GCF there? Well, you don't have an r with a 15, so you can't take out an r. So you got to look at 15, 18, and 30. Well, 5 goes into 15 and 30. 15 goes into 15 and 30, but not 18. So I believe the only thing here would be 3, right? So that'd be 5 plus 6r minus 10r to the 5th, all times 3. So that's just kind of a hodgepodge of everything we've done so far. Factoring by grouping, GCF, and then difference of squares.